So I'm going to start doing some demonstrations for you guys. Hopefully these will work out, and I'll give you time to do these as often as possible. This first demonstration, all right, is a mass undergoing simple harmonic motion. This mass, all right, is attached to a spring right here. We assume, all right, the spring has a certain stiffness, all right. The other end of the spring is fixed. I'll zoom out here for you to be able to see that. All right, doesn't want to do that. Okay, so here I'll just move the camera for you. There we go. See, the other end's fixed up there. Okay, let's bring it back right there. All right, so what I'm going to do is I'm going to pull this down, and hopefully in the camera it'll look like the bottom of the spring is at the negative amplitude there. So you got some definitions there in front of you. The first is the mean position, which is the zero position, the resting position that we saw at the beginning of the this tape, okay, of our mass. The amplitude is what I'm holding it at right now, okay. When I let this guy go, it's going to oscillate, and it's going to oscillate between two amplitudes there, and it's a little bit above and below. I pulled it a little too far, okay. So right now it's also, we have some side-to-side motion, but yep, you can see it oscillating between the X naughts right there, right? So the amount of time it takes for it to go from here all the way up and back down, that completes one cycle. That means it returns to whatever position it was at to begin with, okay? That's the amount of time we call the period. Now, say we complete this period in half a second, okay? That's about half a second there. So the question is, how many cycles are completed per second? Well, the answer would be 2. And that number, 2 cycles happening every second, is the frequency, all right? So let's get this guy bouncing again. Let's see, I think I got it pulled down there. Did I get it? Oh, too far again. It's hard to do that from the side. Anyways, so yeah, I think we nailed all those definitions that you need to know, all right? If I had another mass here, another spring, and I started it at a different time, but they had the same period of oscillation, there would be a phase difference between the two, okay? They'd be separated by their starting angle, their starting time at which they're moving, all right? So those are your first definitions there. Now, when we talk about oscillations and waves, this is an oscillation. This is the most simple model of an oscillation, a mass and a spring. This is the model we'll typically be considering. Sometimes we'll also be considering a mass and a spring on a frictionless surface without considering gravity, because gravity is part of this system actually. So yeah, the rest of the videos are going to be your notes on the smartboard.